So let me do a little bit of review when it comes to the assignment we just did. So I'm going to open up the drawing, the topo file. So on my desktop, on CDA topo, I'll open this and I'll discuss just those 4 items for the surface. Okay, so there's 4 things you need to look at. So if you go to tool space and you look at your surface, expand the surface name and you go to definitions, you should have a boundary, you should have break lines, you should have point groups. So there's 3 things here. Those are 3 of the marks. And then you should also have that get rid of the spikes. I think most people got that right. So in the point groups, I'm using all points. If you look at your point groups, you should see 10 point groups, right? And the point groups are all the ones that you defined in here. Okay, I only did a few. You should have 10 point groups here, and they should all be defined for use under point groups. Okay, so do not use the all points. Use the other ones that you created. So that's 1 mark. So that's the point data. When it comes to break lines, you should have at least 1, maybe 2. To create polylines that are break lines, you want to use everything except the service layers, right? So you want to use the center line, edge of pavement, shoulder, T embankment layer. And you also want to use the T watercourse polyline that you had to create. Remember, there was the double line in this Y-shape area, and then there was a single line through here. So all of those polylines need to be defined as break lines. A common mistake there is to define the red stuff as break lines, draw the T watercourse lines, but then forget to add them to the surface. So yeah, you drew them, but then you forgot to use them on the surface definition. So that was a common mistake. Or not drawing them at all was the other thing, right? So there was a mark for drawing them on the right layer, color, and line type. And then, okay, so make sure you define all your point groups, make sure you define all your break lines, and then the boundary. Okay, and I hope, did everybody use the technique I described? You remember I made a copy of the embankment lines on the outside. Remember I made a copy of this? Copied it over 2000, closed it up, and then brought it back. Yeah, okay, good. That's one way of doing it. That's the way I do it. There's more than one way to do everything, but that's a pretty handy technique. Moving stuff out of the way to a known location and then moving it back. Okay, so kind of undoing the move direction. So how would I add the T course as a break line if I already drew it? So if you drew this in the drawing, right, you just drew it and you've already got break lines added, right? So these might be just the red ones. You could just right click and add some more, right? Make sure you use the proximity, say okay, and add more. And then you'll see, oh, it looks like you did it twice. So that's fine. There's some break lines here and some here. So you could define the break lines that you were provided with and then draw some more and then define those. Or you could draw the additional ones and define them once and for all. The effect is the same, right? Whether you add them, you know, a couple at a time or first few and then the next, or you draw them all first, right, by inserting and then drawing, you know, it doesn't really matter. Okay, so the order doesn't matter. The boundary we talked about, and then the if you go to the surface properties under definition, under the build command in here, you should have the sorry, not build, the data operations. Sorry, is it in here? Why don't I have it here? Analysis. Maybe I didn't do it. Definition, build. Yeah. And nothing. So you want to turn this on, and you want to turn this on and say nothing less than, you know, the low part of the data and nothing greater than the high part of the data. And this was unique. It depended on which topo you did. Okay. The way to find out what those numbers are, again, if you go back, oops, cancel. If you go back to your points and you look at all the points, if you sort them by elevation, you'll see where the zeros are. So in my case, anything less than even 1 meter will get rid of all the zeros. And then if I sort it from top to bottom, anything greater than 200 or 1,000, right? Anything, any number that gets this out of range. So I can use 10 and I can use 200. So then I go back to my existing properties and go back to my build. Right, get rid of everything less than 10. That'll get rid of all the zeros, and get rid of everything greater than 200 or even 1,000. It'll get rid of that odd point at the top. Okay, sorry, 200. and say okay. And if you do that correctly, when you look at the surface, that's probably just off. Turn on all my layers. Regen. There's my surface, and when you look at it in 3D object viewer, then you'll see a few things. Now, some of you might see something like this. See the streak through here? If that's true, it means you may have defined some of the sewer lines as break lines. Remember, you don't want to use those, right? So I left that in there intentionally. Why are these warning messages? Why are there warning messages when correcting for spikes? Because it's telling you, hey, data that you defined, and now you're eliminating some of it. Do you really want to do this? Okay, so you will get warnings occasionally along the way, but they're just letting you know technically things are happening, but we're accepting them. Okay, so a lot of the warnings we don't need. Okay, if you have warnings and you're not sure, you can ask me, but generally we can ignore a lot of the warnings. So that's what the surface looks like. Okay, and then again, you had a different style and so on. So if you did all that, when I look at, and this is how I marked it, right? I look at it in 3D, object viewer. I look at it in 3D, I take a quick look. I can tell whether your break lines are defined or not. The roads should have that arrowhead pattern, right? You can see that nice and clean here, all the way along the road, that arrowhead shape. The water course should be nicely defined. You can see mine isn't, right? These points are not connected with a nice smooth line in the invert of the creek. And even in here, it looks kind of jagged, right? So my break lines are not all complete. I added some, but I didn't draw some, so they're still missing. Also, why are there error messages for the water course break lines? When you define them, sometimes if you have more than one and they're touching, they have a common point, it thinks that they're intersecting, so it gives you warnings as well. For the most part, the stuff I've asked you to do, you don't have to worry about it. Okay, all those errors you can ignore. Okay, so now this is the surface going forward. Now that you have this surface and it's good to go, you can now carry on. If you don't like that error there, I think it's because, again, I had these layers on. So let me do this again. I should have the center line, the shoulder, the edge of pavement, and the embankment layer. These are the only break lines. So let me just fix this. If you had that weird line kind of through it, I'm going to delete the break lines, delete, say yes. Again, I'm still missing the, and then if you see these warnings, again, hey, you changed some of the data, it wants to know whether you should rebuild it. If you don't want to be warned on the surface, you could set this to automatic. So every time you make a change, it'll automatically rebuild. So finally, I'm going to add break lines, make sure they're always proximity, say okay, select everything, and that should fix it all. I'll just turn everything on. And if you don't see the surface when you turn everything on, you might have to regenerate the view. Okay, and now it fixed that problem. Remember that weird kind of shape through here? It's now gone. So this is how I mark it. I look at everybody's, in 3D, and I make sure, I can tell there's no spikes, and everything looks pretty good. Okay. The other stuff, if you didn't get perfect on the other stuff, it's mostly cosmetic. It's really, did you follow instructions or didn't you? Okay. So if you didn't get something and you're not sure, time, I can answer some questions later. But I want to get started today with the next assignment so people can get going. And then if there's any individual questions, you can ask them during class, or we can have a private chat. All right, assignment 2. So I'm going to close this now. Say yes, I've made my fixes. I'm ready to go. So if you've downloaded all the files, let me start with the assignment 2 file. Excuse me. So this is the assignment 2. There's 2 pages. Doesn't look like much. Don't be complacent. Just because there's only 2 pages doesn't mean there's not a lot of work to do. In this assignment here, we have to create a new drawing. We have to use that metric template again. So exactly what we did in assignment 1 to create the DWG called topo, we're going to do that again to create the base plan. Okay, so we're going to do all of our design work in a different DWG called base. And then we'll interact, the 2 drawings will kind of interact with each other. We'll learn about X references, we'll learn about surface references, and so on. okay? There's a bunch of layers here. Some of this stuff you have to create. Some of it's already in the drawing. I think it might be. If it says create and they're already in the drawing, right, by these layer names, then use them. If they're not there, you have to create them. I forget whether I included them or not this year. Sometimes I leave them, sometimes I don't. You'll get some layers for free from the insertion that you perform. Okay, so you'll see some of that when you look at it. These are existing layers, and these T-dash layers are actually, we're going to insert them. Okay, so we want to actually see that, I think I asked you to insert the DXF. Oh, sorry. These layers you're going to get through the X reference. Okay, so we'll talk more about that there. And here's everything you want to do, right? There's a bullet list of all the stuff we need to do. We're not going to get to page 2 today, okay? And then the general requirements for the drafting is here. Okay, we'll talk about that later. Today, I just want to talk about this bullet point 1, okay? If you took CRX and you drew a plan profile before, then this will be very, very familiar, okay? I want you to draw the center line of the road. I want you to draw the edge of pavement. I want you to draw the back of curb, the sidewalk, the storm and sanitary sewer layout. I want you to draw the maintenance holes in the pipes. I'll explain where they go. I want you to draw just the center line of the water main, very basic, okay? I don't care about hydrants or valve chambers or bends or T's or anything like that. I just want to draw the center line of the pipe. And that's all we're going to do with the water main, okay? This entire exercise, this drafting, it's a design exercise, but really what you're doing is drawing everything where it needs to go based on the standards, okay? So we'll talk about how to draw all this stuff. This first bullet should be your homework. If you can get this done for tomorrow, you'll be in good shape, okay? But I'll show you an example. I'll do a little bit of a demo about all this stuff. But we need to get started, so we have to follow this thing here, okay? So I'm going to demonstrate this, and then I'll give you an opportunity to do class, just like we did with the topo file. All right, any questions so far? Okay, I'm going to get ready to start. So please download those files from the course documents or from assignments, Module 2 and Assignment 2. Put them in that directory under Downloads, and you should have everything you need going forward. And lastly, find out what site you were assigned. Okay, so here's how we're going to start. We're going to go, and again, I use the pull-down menus, so I'm going to go File, New. When you do that, it takes you to these templates. These are right out of the box, AutoCAD provided. We're not going to use these. We're going to use the one that I gave you last time. So you have to go to Module 1 for this one. So you go to your desktop under the course code, under Downloads, and you want to go to, not Module 2, there's nothing there. You got to go back. We're going to use the same metric template that we used for the first assignment. Okay, so make sure you use the metric template. So you have it from before, Module 1. Open it. It creates a drawing. The drawing name, it starts indexing it. Drawing 2. Check your DD units. Always check your DD units. Make sure it's in meters. Very good. And then we're not doing anything. File, Save As. Put it in the same directory as your topo, but this one's going to be called Base, B-A-S-E. So now you should have 2 drawings. Okay, and there's nothing in it. There's just a bunch of settings. To double check, make sure that you use that template. If you go to Settings, if you go to Surface, if you go to Surface Style, there should only be 2. If you have more than 2, if you have a long list, then you use the wrong template, and that's going to cause you grief for the rest of the semester. Okay, so please make sure you use that template that I provided, the one you downloaded from Module 1. And I think most of you did that correctly the first time. Okay. So that's how you create the new drawing, and that's it. For this course, we're only going to have 2 drawings. We're going to have a base and a topo, and most of the work you're going to do going forward is going to happen in this base drawing now. Okay, for the rest of the assignments, 2, 3, 4, 5, and 6. Okay, so take a few moments to create this drawing and save it in the appropriate place. Again, please follow put it on your desktop, put it in the course code, put it on the downloads folder, and start to organize yourself this way. If you use the same directory standard structure that I'm using, then if you have any problems, I can help you. I know where things are supposed to be, and it's easy to find them. If you use your own filing system, we're just going to waste time. I'll have a hard time helping you, and I'll have a hard time getting to other students, okay? So it's good practice for yourself, and it's a respectful practice for everybody else. And the reality is when you go to your first job or you go to a company, they're going to have a standard they want you to follow. So this is the standard I want. This is how I want you to store the information. Okay, so take a few moments to do that and make sure you create this drawing. Okay, so if you look across the top, the drawing name should be there and so on. All right. Any questions while we're here, while we're waiting for everybody to catch up? Please do this in class. Don't leave today without this. That way you know you started the DWG correctly. Okay, what happens next? Again, this is one of those times where I'm going to ask you try not to keep up with me. I'm going to go a little faster than you might, just based on my experience. This is kind of sit back, fold your arms, and just watch. Get the preview of what you're going to encounter, what's going to happen, and then you can always come back and review the video. There's also a couple more PDFs in the series of guide documents. Can you go over opening the drawing correctly? Opening the drawing or creating a new drawing? Jamar? I'm not opening anything. I'm creating a new one. Okay, so you go to File, you go to New, and then don't use these. Navigate to the desktop under the course code, under Downloads, under Module 1, and choose this template. Okay. Okay, so now we want to bring in the file that represents the subdivision. So now I'm going to insert, I for insert. I'm going to use this ellipsis button here, this triple dot button. I'm going to, not module 1, but I'm going to come out, right? So I'm going to go to the desktop, CDA 543 downloads module 2. And if you don't see the site plan, it's because this is set to DWG. Okay, so if you don't see anything, you have to change this to DXF, okay, the data transfer file. There's the site plan for this year, right? I change it up every year. So this is this year's version, site plan 2020, say open. And then once it comes up, you want to do a couple of things. Whoops. You want to turn this off. You want to insert it at 0, 0, 0. You want the scale to be 1 across the board, and you want the rotation angle to be 0. That's standard practice in industry, okay? And when you bring it in, you could on the fly during the insert command is exploded, okay? So everything should be off except the last setting. And then you can go up to the file and double click, and it'll insert it into the drawing. Okay? You can close this. If you don't see anything, Z, enter, E for extents, enter, and you should see this. And you can kind of see the shape looks familiar, right? You can see the bounding road that goes all the way around the 4 sides is the same shape as the topo. Okay, so it is geo-referenced. It is related to the topo that you were given. So now if you go to your grade center and you look at the column called site, you'll see a letter, A, B, C, D, E, F, G, H. Okay. Is the DXS already? Yes, it should be. Okay. And we'll be able to demonstrate that later. Okay. When it comes in, it should come in. We're going to check a couple of things, but I'm pretty sure it is. But that's a good question, Stephen. If you're not sure, open it and do what we did last time. Right? But I'm pretty sure I left it in metric. So now, if you know what site letter you are, Stephen, I'll pick on you. What site letter were you given? A, B, C, D, E, F, G, H. What letter were you given? Go to grade book. F. So you're site F. So if you zoom in, you'll see the street names. Here's street A, street B, C, D, E, F. So Stephen, this is your site. Okay. So as soon as you know what site letter you are, Stephen, this is what you should do. First thing I'm going to do is I'm going to turn off the layer for the main roads. And then I know this is mine, street F. I'm going to erase the others. I'm not designing these. Okay? These were not assigned to me. I'm going to delete everything except my site. Okay, so there's street F, and if I turn everything back on, there, that's it. That's the project for you, Steve. Okay, so whatever site letter you were assigned, that's the one that you should keep. Erase the others, just like the topo CSV file. If it's not assigned to you, get rid of it. Okay, and that's what I want you to do next. Okay, so I'm just going to bring all of these back. All right? If I'm site letter G, that's my site. I erase everything but G, and that's my responsibility now. These are not about me. Somebody else is doing those. So that's site G, turn everything back on, and that's what you should see, okay? So find out what letter you were assigned. And again, make sure you use the letter that you were assigned, because later, when I'm gonna be marking stuff, what you should create and produce is related to which site letter and topo number you were given. So if you don't use the right site or you don't use the right topo, you're gonna produce data that's gonna be different than what I'm looking for, and you're gonna get stuff wrong, okay? So you have to make sure that you use the information that's provided to you specifically. Okay, so if you want to take the time to do that, you can, and then we'll do a couple of things. Okay, I'm just gonna, I'll be right back. Just gonna go turn off some noise. Just a second. Sorry about that. There was background noise I had to get rid of. My apologies. Can you please show how to insert the drawing in? Yep. So if you type in I for insert, and you use this ellipsis button, you navigate to desktop under course code, under downloads, under module 2. If you don't see a DXF, it's because the file type is set to DWG. So change it to DXF. You click on it and say open, and then these are the settings. Turn everything off except the last one. Okay, and that'll explode it as well. And then to put it into the drawing, and if you want to change it to list so that you can see it, there's the name of the DXF that you want to insert. Just double click on the file name here, and it should show up. This menu, you don't see it, should be there. Type in I for insert. Right here, type in I or type in the whole word, insert. Okay, if it doesn't show up, then it might be hidden behind or something. If you want, you can type in negative insert, and you can actually, that's not a good idea. They won't give the dialog box. It should show up. It might be stuck somewhere. If you don't see it, it might be like off to the side here, down here somewhere. Right? If you get rid of your tool space, it might be stuck in here, and if you don't see it, it might be kind of closed off somewhere. Okay? Maybe minimize your drawing, and then you might see it. If you can't find it, I'll help you. All right, so we brought it in, so everybody should have it. Does anybody not know their site letter? What did I type? You typed something in after you inserted the DXF. I don't remember. Z, enter, E, enter. I zoom extents. Yeah. Because what happens is, you're zoomed in here. It's in the drawing in the right spot, but if you don't zoom extents, you won't see it, right? You're zoomed in somewhere over here where there's nothing to see. Okay, so when after you insert it, zoom extents. Okay, so now if everybody has their site, again, delete the ones that weren't assigned to you, zoom in and tell me, don't go near the intersection, don't go near this bulb, this kind of crescent or bulge here in the corner. Everybody's got one of those. And don't go anywhere near the bulb, like the end, the dead end part. Somewhere in the middle, measure the distance across. How wide is the right of way? So measure the distance from a near point perpendicular across the street. How wide is the road? This is the right of way. Okay, this will do two things. I need to know how wide the road is, so I know what standard to use, and I need to know if it didn't get scaled, right? The DXF was in meters as well. So measure across how wide is the right of way. Okay, again, stay away from this elbow, from this bulb, and the intersection. Just look at like a constant width. Yeah, okay, so here's how you do it. Distance, I'm gonna, DI for distance. I'm gonna snap to a near point on one side, and then I'm gonna snap to the perpendicular across the way, and it'll tell me, yep, it's exactly 20 meters. Okay, so this is a 20-meter right-of-way. It should seem familiar. Okay, when I taught CRX last, we were using the same 20-meter right-of-way. Okay, and we're also going to use the same standards that you used in CRX, or at least what I taught the last time I taught that course. We're going to use the Town of Richmond Hill standards. So now we need to look at that and what it means. So this is everybody's doing approximately the same length of road. You've all got the same number of lots. So if you look at the lot numbers, right, they usually start here, 1, 2, 3, 4, 5, 6. They go down one side and come back up the other side. So you should see everyone should have 36 lots. And the length of the road is approximately the same. And every road has an intersection to create with the existing road, what we call a crescent, or sometimes called an eyebrow or a knuckle or an elbow. It's got many names. I'll discuss that a little bit later, but there's so many ways of calling this feature here. And then there's the cul-de-sac, right? A turnaround point on a dead-end street. These three features are typical on a lot of local subdivision roads. Okay, your standard width of 20 meters, right, in Richmond Hill, and then you've got these kind of intersections, knuckles or crescents to deal with, and on occasion you might have a dead end to deal with. You can design these three items plus the standard width of road, then you've covered at least 90 to 95% of anything you're going to encounter when you're doing residential subdivisions. Okay, so it's a pretty good skill set that you can take with you. What changes from one road to another is the geometry, right? But how you do the design, what you do first, what you do next, the design process will remain the same. So I'm not going to highlight the design process. We will follow it, right? But that's not front and center in this course. This course mainly deals with the tasks, the drafting and Civil 3D tasks, the skills you need to design subdivisions. We will follow the design process. So when I ask you to do this first and then that and then that, that's just step-by-step instructions for this course. But really, in a broader sense, they're the order of operations when you kind of design any subdivision, okay, any residential subdivision. All right, so we will deal with both technical skills and design process. The emphasis is on the technical skills, but the design process is necessary. Okay. Next semester, when we do MED, we'll talk a lot more about the design process, and I'll expect you to have these skills that I'm trying to teach you in this course, or that I will teach you in this course. Okay. So before we continue, we need to know what those tasks are. So let's talk about the design process a little bit. If you go to the document that I gave you for the assignment, and we look at that list in the first bullet point. So let me zoom in on this. I want you to draw the center line of the road. I want you to draw the edge of pavement. And there's a very detailed discussion about what that statement means, edge of pavement. The back of curb, the sidewalk, the storm and sanitary pipes, the storm and sanitary maintenance holes, and the water main. Okay, so it says here, draw all that as discussed in class on the appropriate layers. Okay, so we're going to discuss it right now. How do you draw all this stuff? Again, order of operations. What should you do first? What should you do next? Well, I would do everything in this order. Okay, draw the center line first and be done with it. Then draw the edges of pavement everywhere and you're done. Then you get the back of curb from the edge of pavement. Then you can draw your sidewalks. And then you can deal with sand and storm pipes together. They kind of go hand in hand. You'll see why. And then finally, you'll deal with the water main. Okay, these are the things that I want you to start drawing. So I'm going to do a little bit of a demonstration of each. Okay, so how do I know where to draw these items? Well, you have to look at the town standard for a 20-meter right-of-way in Richmond Hill. That's the standard I want you to use. So I'll look at that document next. Okay, so one of the things you downloaded in Module 2 should be this file here. Engineering and Public Works Standard Specification Manual, and you'll see this is for the town of Richmond Hill. Okay, it's a pretty big document. Okay, I'm going to point you to what you need exactly for this particular assignment. We will be dealing with this throughout the semester, and not the whole document, but at least the pieces that are related to what I'm teaching. So if you open up this document, it's a PDF. It's actually a pretty good PDF where it's searchable, right? It's a text file. It's got bookmarks where you can quickly go to different sections. So for today's class, I'm just going to collapse everything. If I remember how to do that. Collapse top level. Okay, so these are the kind of the chapters of the sections of the book. So Division A deals with sewers, both sanitary and storm. Division B with water main. Division C with transportation. So most of what you need to draw is related to the road. So we're going to look in Division C first. And in Division C, we want to now find the information we need. So I want to find the standard cross section for a 20-meter right-of-way. So I'm going to just scroll through this very quickly, and I'm going to go where the drawings are for this section. So it's usually near the end. Okay, here we go. Here are the cross sections. Okay, so this is on page 162 of the PDF. If you look here, you'll see a typical street cross section bigger than 18 meters. Right, so this is standard R1A. The next one is an 18-meter right-of-way. The next one is a 20-meter right-of-way or greater. And the next one is an 18-meter right-of-way, and the next one is a 17-meter right-of-way. So there's many different kinds. So there's 1, 2, 3, 4 different standards, 5 different standards for cross sections. Okay, which one are we going to use? I want you to use the 20-meter right-of-way and greater. So this page here. So standard R1B. R-1B is what we're going to use for the cross section. Okay, so this is for 20-meter right-of-way and greater. We have exactly 20-meter right-of-way. Okay? So the thing about this is it can be used for a 20-meter right-of-way or anything bigger. And to know the dimensions, there's 2 variables on this sheet that we need to figure out. The first is we know we're dealing with a 20-meter right-of-way. So if you zoom in on these 2 dimensions right here, this dimension, whoops, let me highlight, probably not. This dimension here we know is 20. We measured from street line all the way across the street line, it's 20 meters. If I know it's a 20-meter right-of-way, then I can figure out what the width of the pavement is, okay, how far it is across the pavement part of the road. Okay, so if I know W, I measured it in the drawing, or sometimes you get it from the surveyor and it's already labeled as 20 meters, then I can go and figure out what R is. So this drawing by itself is not enough. We have to go back into the document and look at another page that deals with these dimensions, okay? So keep in mind R1B. If I know this is 20, how do I figure out what this is? Okay, and the document for that, I'm going to go back a few pages. There's a table. The table is right here. So this is the table, Division C, Section C12. It's on page 130. So you need this to read together with the drawing standard R1B. And what we look at is, remember the dimension W, the right-of-way? Well, that's this column here. So if I know the width of the right-of-way, whoops. If I know the width of the right-of-way, which is this column here, then I can figure out the pavement width minimum, this column here. So remember the drawing, the width is called W, and then the pavement is called R, the variable R. So if you know W, you can figure out what R is. So the dimension was a 20-meter right-of-way. So we're dealing with a ULU, urban local undivided road. Okay? It's a 20-meter wide road allowance. And if we know that that's what we're dealing with, then we can determine the width of the pavement. So if dimension W is 20, then dimension R is 8.5. Okay? So you use this table together with that other standard. So if the width was 23, you'd use 8.5. If the width was 23, but you were doing a minor collector, you'd use 975. If the width was 26, you would use 11.25 and so on. So basically the one drawing covers all these cases. You just have to know which one. Okay, so we know we're dealing with a 20-meter right-of-way. It's the only one. And we know it is a ULU. It's the only urban local undivided road. And if you thought all the stuff you learned in highways was a waste of time, here it is, right? These are the road classifications. So a ULU 20 has a pavement width of 8.5. So if we go back to page 162, if this is 20 whoops, if this is 20, then this is 8.5. Okay, any questions about that? Okay, so I want you to use, whoops, wrong one, standard, this one, 20 meter right away, R1B. So if we know this is 20, we know this is 8.5, and we know it through that other document. So look at page 130, PDF page 130, and then look at page 164, the PDF pages. Okay. Later we'll learn different reference. Really, it's standard R1B, read in conjunction with table. Division C, section C, 1.2. Okay, that's the real reference. Okay, any questions about that? So for this cross section, if you look on both sides, how wide is a boulevard? How wide is the boulevard on the left? How wide is the boulevard on the right? Yeah, you'll notice it's symmetrical. So it's 575 on one side, 575 on the other side, and then the pavement is in the middle. That means the center of the pavement, right, or in this tangent section, the middle of the road crown, right, the pavement crown is right in the middle of the right-of-way. So if this is 20 meters, if this is 20 meters across, how can I find the center line of the road if I want to draw that in the plan view, right? I have this line on one side, I have this line on the other side. Yep, Daniel, you got it right. So if I use one of the right-of-way lines, I can offset to the center of the road by 10 meters, and that will find the center line of the road. Okay, so this is, I don't want to say it's a mystery, it's not a problem. It's something you need to look into, right? What kind of road am I designing for? I know it's a ULU 20. I know that the width is 20. I know that the pavement the dimension is 8.5. Based on this section, I know that the center line of the right-of-way is the center line of the pavement. I can now draw my center line throughout on this typical 20-meter right-of-way. There are exceptions, and you'll see when we go to draw this. What happens through the bulb, the cul-de-sac, what happens in the elbow, and how we deal with it at the intersection, you have to look at it in a little more detail. But generally speaking, it's a 10-meter offset to center from either side. Okay, everybody good with that? So if I go back to my drawing, oops, I know this, and if it's all one continuous polyline, you're gonna have a hard time offsetting it. It might not let you offset 10 meters. It may not let you do it. Kind of wacky stuff happens. See that? It's kind of weird. So I'm going to get rid of that. And I'm going to explode it. And I'm going to offset using one side. Okay. Now when you're coming around, just use don't deal with this elbow, this kind of widened stuff. Leave that alone. And don't worry about the cul-de-sac, right? And ignore the intersection. Just look where the standard 20-meter widths are. Right? This is 20 meters, this is 20 meters, this is 20 meters, and so on. Okay, actually that one might be wrong. I have to check that. Okay, this one might be wrong. We might have to fix that. Anybody who got G might have a problem. I'm just looking at it now. These should be concentric. Anyway, we'll deal with that. I usually use the inside. So I'm going to offset 10 meters. There's the center line of the road. I'm going to offset 10 meters. There's the center line of the road. There's the center line of the road. There's the center line of the road, and I'm done. Okay, this is unusual. It's not exactly 20 meters wide. This is not exactly 20 meters wide. So where you have a standard width, across from here to here is 20, choose one side. Across from here to here is 20, choose one side. Across from here to here is 20, choose one side. Okay, so you can establish the center line of the road. I'm G, so I'll have to adjust that. Yeah, I think a mistake here. I'm just looking at it. I believe if I offset 20 meters right here, it's non-standard. Yeah, that's a problem. So I'm going to get rid of this, and that should be your right away. Then it's parallel on both sides. Yeah, I made a mistake there. Okay, nothing. Remember I said nobody's perfect? Here's an example of me. I screwed this one up. And then if you do that, you can extend all of the street lines to the curve. Okay, my mistake. So now you can offset from this side or this side, and they are concentric. They should be parallel. Yeah. Okay. A note to those of you who have site G, my apologies. The rest should be okay. I checked them. Maybe this was the last one I was doing and I fell asleep or something. I'm sorry. All right, so that's how you draw the center line. Now, how do you deal with the center line in these unusual spots, right? How do you deal with it at the intersection? Well, we always take the center line across the street to the opposite right-of-way. So the center line of the pavement is here. We don't go to the middle of the road, we go to the opposite side. So that's where the alignment starts. So that's how you deal with the intersection. When it comes to the bulb and the crescent, we have to look at a standard. So let's look at these standards again. So we go back to here, and I'm going to look at these two drawings. Here's a cul-de-sac standard, and here's a crescent standard. Okay, let's deal with the cul-de-sac first. If it's symmetrical, then the center line on a typical 20-meter right-of-way should go right through the center of the circle and beyond all the way to the opposite edge of the right-of-way. So let's see if that happens. So in here, I'm going to extend to here, this. This should have gone right through the center of this circle. Here's how I'm going to check it. I'm going to draw a line from the center of the circle, and I'm going to trim that center line. And now if I grip both, if I go to move this, they should both move together. It means there's a common point there. And that looks good. It's right in the center of the right-of-way. As a matter of fact, this point, that blue dot, and this blue dot from these two lines are in the same spot. It's the same as the center of this arc. So that is encouraging. Everything's in the same place. Okay, so I know all I have to do is extend the center line to the end of the right-of-way. So this one goes to the opposite street line, and this one goes to the end of the street line and the bulb. Okay, so that's two things. So the intersection, the bulb, how do we deal with this? Well, now we go to the standard for the crescent. Okay, so this is on page 167, typical cul-de-sac R3A, and then we go to page 168, which is standard R4A, and here's how you deal with the crescent. What is the radius of the center line when you go around this crescent, as it's called? Typical 90-degree crescent. The center line of the road. Anybody else? Yeah, I think you're getting it. It's right here. All right, center line of the road is 14.5. So we drew this line by an offset. Yeah, I'll get back to it. So here's the center line of the road on one side. Here's the center line of the road on the other side. What you need is to put a radius in there of 14.5. And what command would you use in AutoCAD to do that? How would you establish that? Yeah, exactly. So I'm going to use a fillet with a radius of 14.5 and connect this to this. And now I've got my center line geometry. Okay, I'm going to draw that all from scratch. Okay, so offset where you have a standard 20-meter right-of-way, 10 meters. Right, so there's typical, there's typical, there's typical, there's typical. What's atypical? When you get to an intersection, you extend to the opposite right-of-way. The center line of the road is here somewhere. I go all the way across the street to the other side. Here, I'm going to extend to the end of the circle, and that's all you need to do. And if you want to check it, again, draw a line from the center of the circle. If you trim off your center line, that should be a common point. Okay, so double check that, but I think I was pretty good about that. So again, extend to the end of the circle, and then in here, you're going to use a fillet with a radius of 14.5. Not because I said so, because that's what the standard tells us. Okay, so there it is, 14.5. Okay, so you can see to draw that center line, I had to go to a few different pages. Okay, and this is the nature of design, right? I need a dimension. I need to know how to deal with the crescent. I need to know how to deal with the cul-de-sac. I need to know what to do at an intersection. Now the intersection to go to the opposite right-of-way, I'll explain more about why you need to do that. Okay, but that's common practice. We don't stop at the center of the road. We go all the way to the opposite side. This is the crescent. Again, there are other names you'll hear in different documents. This is called a crescent. See how it kind of bulges out on the outside of the turn? They're actually creating, a wider pavement as you come around the curve on the outside. And that's so that they have more frontage here, so they can have more lots on this corner, right? If you don't do that, then you're going to have very narrow frontages. So it's really an architect's trick of getting more property line across the front in this corner. So this is called a crescent. But there are other names for it, and they're always body parts. I don't know why. Instead of a crescent, you'll hear terms like elbow, knuckle, or eyebrow. Okay, those three other terms you'll look, and I sometimes use them interchangeably. But in Richmond Hill, they call it a crescent. Okay, it says typical 90 degree, None of you have a 90-degree crescent. Okay, so you're going to have to interpret this and get the dimensions you need for your particular application. Everybody's going to have one elbow, and everybody's going to have one cul-de-sac to deal with. Okay, the only thing you've been given on the drawing is this dark line around the outside. That's the right of way, right? And the two dark lines around the outside, right? You have to draw the center line and the edge of asphalt. The edge of pavement and the back of curb. This double line on both sides throughout the subdivision. Okay, so we'll be getting to that. That's right. Yeah, so if you go back to the standards, you put the center line on this layer here with this color and line type. Yeah, so you have to adhere to that. I wouldn't waste too much time with the layer control. You can do that after you create everything, right? So once you create the center line, then you can go ahead and make sure it's in the correct location. How do we make the fillet round? Just type in, if you get rid of that, delete, right? F for fillet, R 14.5, and then you pick the two ends. Click this and this. Yes, Trung, I was getting to that. So now that you've got all the center line geometry, it's always good practice to connect all the pieces. So these are lines and arcs, PE for polyline edit. Pick one. It's going to ask you to turn it into a polyline. Say yes. And then select everything else for join, J for join, and pick these and join them once and for all. So now you have a polyline from beginning to end, and that's the center line geometry polyline. Okay? You don't have to do that, but you'll see the advantage of doing it. Okay, so that's your center line of road. So everybody has to create that. Then your edge of pavement. Okay, so the next item is, so we did the center line, now we need the edge of pavement. To look at the edge of pavement, we have to go back to the standard 164. Remember this cross section? Here's where it gets confusing. The language is a little bit loose. Okay, so in the town of Richmond Hill, when someone says to you edge of pavement, they actually mean not the edge of asphalt, but the gutter. So if you look at this dimension R, it goes to the low point in the gutter. So from this gutter point across to the opposite gutter point, that width is called the pavement. Okay, so they allow the offset of the gutter to be part of the pavement definition. So this is the edge of asphalt. This is the gutter. In Richmond Hill, when they say pavement, they mean gutter to gutter. And you can tell by this drawing, right? You can see the dimension line, this vertical line goes to the gutter, not the edge of asphalt. So we don't even draw this in the drawing. We draw the position of the gutter. So when I say to you, draw the edge of pavement, and we're dealing with Richmond Hill, I really mean, more specifically, draw the location of the gutter. Is everybody clear? Okay, and I'm not doing this just to cause you grief. It's the reality of the situation. The word pavement sometimes means the gutter, sometimes means the edge of asphalt. Local collector roads, they allow the pavement definition at the gutter. When you get into the higher class roads, when you go to arterials and freeways, the pavement goes from edge of asphalt to edge of asphalt, and then that's extra. Okay, so it's important you understand that, and really you have to pay attention to the standard drawing. When we say pavement, do we mean gutter to gutter, or do we mean asphalt edge to asphalt edge? In Richmond Hill, for local roads, gutter to gutter is what's defined as the pavement. So the edge of pavement is draw the gutter line position. Okay, so to do that, you need to know how wide the road is. So how wide was the road? How wide is the pavement? What's this dimension R? Everybody remember? If you don't, you have to look it up again. And if the center of the road is the center of the pavement, how would we draw the gutter line on one side? Exactly. So we're going to take the pavement, divide it by 2, and that's your offset from center. So that's what I'm going to do next. And again, I'm not dealing with layers and stuff, right? But this has to be on the right layer. It's got to be the right color in the line type. I'm not going to do that. I'm just going to do the geometry. So I'm going to offset 4.25, and I'm going to use that center line. Okay, so there's an edge of pavement on this side, and there's an edge of pavement on this side. Okay, and that's generally it. There's your edge of pavement. Now, obviously, in the crescent, it's wrong. In the cul-de-sac, it's wrong. And in the intersection, it's wrong. So we have to fix those 3 locations. But the general position of the edge of pavement is 4.25 meters off of the center line. Okay, so now for the to draw the 3 positions, right? The cul-de-sac, the crescent, and the intersection. These 2 are very similar. What you do here and what you do here is almost the same procedure, but the geometry is different. This takes a little bit more thought. Okay, so I'm going to show you the crescent. I'm going to describe it. Okay, I'm not going to draw it for you. I want you to draw it, but I'm going to describe it to you. So let's go to the standard for it. So back to the drawing, because you have to be able to interpret these standards and draw the solution yourself. Okay, so if I just show you how to do it, you're not going to learn anything. I want you to try it. Okay, so the standard we're looking at is here. Okay, so the big thick line on the outside is the right-of-way, which we have. Leading into the cul-de-sac, right, the right-of-way, standard 20, ROW 20. And then we have the center line in the middle, all the way through the center of the cul-de-sac, and then we get these arcs. So to go around the cul-de-sac, this double line, these 2 lines right here, one of them is the edge of pavement, which is the gutter, and this is the back of curb. Okay, so to draw the gutter line, okay, ignore the back of curb for now. To draw the gutter line, which is the edge of pavement, this position here, we need to draw the geometry for this. Okay, so we need to make sure that this edge of pavement is in the middle, right? The center of the pavement is still the center of the right-of-way. Okay, so the center point for the curve around the outside here coincides with the center of the right-of-way, and then the radius to the pavement is given here. And then you'll see the radius for coming around here and around here. It's not labeled on this side, it's only labeled on this side. You'll have to use the appropriate radius. Okay, so you need to draw 1, 2, 3 arcs. The information you need to draw those 3 arcs is right here. Okay, so that's all I'm going to say. I'm your boss, draw this, and let's see how you do when I mark it. Okay, so I'll tell you how you did after you hand it in. Okay, so all you really need to look at is what are the radii and where should the arcs be. In a very similar way, if you go to the crescent, you have a similar situation. On the outside, there are 1, 2, 3 arcs. There's an arc here, there's an arc here, and there's an arc here. The radii for those 3 arcs are given. Okay, the radius for the 3 arcs are given. This one's not labeled, it's the same as this, it's symmetrical. Okay, you can see this arc and this arc are the same. Now, because all of you have crescents that are not 90 degrees, the only thing you can use from this drawing are the radii. So if it says R equals, that's what you want to use. If it says A equals, A, and A here, that's the arc length. The only time you're going to get that arc length, the length of the curve, here, here, and here, and down here on the inside, the only way you're going to get those arc lengths is if the angle between this line and this line here is exactly 90 degrees, which it's not. Okay, so ignore the arc lengths, just use the radii here. Okay, and I'll leave it up to you again to draw the edge of pavement. Draw a circle, if you say so. I'll let you know after you hand it in, Daniel, okay? So you need to interpret this. So you got to look at this and see what the information is, and then kind of plan, how you're going to attack it. What should you do first? What should you do next, and so on. Okay. So again, I'm going to leave that up to you. So interpret this drawing and the other drawing, and draw the edge of pavement everywhere. Okay. I will discuss the intersection in a lot more detail now, though. Okay, so I will demonstrate that a little bit more. But these are the 2 standards you want to look at, right? The crescent and the cul-de-sac. So this right now is wrong. This right now is wrong, and I'm going to leave it like that. I'm going to have you fix it, figure out what you have to do. The intersection now, to get the intersection to work, you could now X-reference the topo, so you can see where the edges of pavement, edges of asphalt are, and so on. Or you could insert the DXF file. Okay, I usually like to use the X reference. I've already drawn the lines in another drawing. I don't want to go through that exercise again, so I want to see that line work here. So what I'm going to do is I'm going to X reference. Okay, XREF, external reference, and I'm going to go to a DWG, and I'm going to go to my desktop under course code, topo, say OK. And now it's like inserting a file, but you're not going to explode it. You can't, right? So make sure The scale is 1. Make sure the insertion point is 0, 0, 0, and make sure the rotation angle is 0. So this should be off, this should be off, and this should be off. And then double check, make sure both drawings are in meters, and they are. It's telling you it wants to convert meters to meters. That's good, a scale factor of 1. Okay, so just double check all that. When you say okay, it should fall right into place. And there it is, okay? That's not a coincidence, right? They're both using the same coordinate system, okay? See everything there, so I'm going to just freeze a couple of layers. First thing I want to do, in the X reference layer top, I want to one called tin. So this is the layer that the surface is on. I'm going to freeze it. I don't want to see the contours. If I regen, that should disappear. And it doesn't. It's probably on the wrong layer. It should be on layer 0. It shouldn't be on layer 0. It should be on the C10 layer. Let me just check that. Otherwise, it's not going to disappear. Because you can't freeze layer 0 when you're working in a file. So let me just double check this. A little bit of housekeeping. We talked about this last day. If I list this, it's on layer 0. Well, that's no good. So I'm going to change the layer of this item to layer C10. Okay. Take it off layer 0. So now when I list it, it's on a layer called C10. Good. I'm going to save the drawing. I'm going to close the drawing, and now it's going to warn me in the base, hey, you need to reload it because you made some changes. Well, the layer that the surface is on is now frozen in this drawing, so it should disappear. And now it's gone, right? Then we also want to freeze the P' layers, all the points. So I'll freeze those for now. And I can start to see just the line work. So if you zoom in here, you can start to see all the servicing information for the intersection and all the edge of pavement and so on. So let me just turn a couple more things off. I don't want to see the sewer information or the text for it. I don't want to see the hydrant information or the text for it. I just want to see center line of road, edge of pavement on both sides, and edge of shoulder on both sides. Okay, so let me turn off a couple more things. I'm going to turn off the embankment layer. I'm going to turn off the shoulder. And this is the boundary, I think. Yeah. So now I have center line of the existing road. I have edge of pavement on the existing road, edge of pavement on the existing road. And then for the proposed road, I have center line, edge of pavement, and edge of pavement. Okay. Now again, that term pavement is confusing. This is an urban road. And when I say edge of pavement, I mean line to gutter line. If you remember, this road here has a shoulder. So this is a rural road. It's not an urban road. There's no curb and gutter on this road. So now how do I connect this gutter line to this road here where there's no gutter? Okay, and this is the trick. Connect this to where the gutter should be on this road. Okay, and there's a certain radius. If you look at any intersection, let me see if I can do this. If you look at any intersection, not just Richmond Hill, but in general, let me go to Google Map. There is what's called a curb return. So let me go to Google. I'll go to Map. Oops. Google Maps, and if you zoom in on an air photo, satellite image, if you zoom in, we'll go to Richmond Hill, but it's the same everywhere. So Richmond Hill is here. If you zoom in at any intersection, you'll see the asphalt is curved. See these curves here? Right? When you go around an intersection, it's curved. Let's look at a four-way, so we can find a four-way intersection. Right here. Right? You can see there's a curve here on the edge of asphalt. There's a curve here where the gutter line is, right? So you have these curves. To create these curves, you're going to use, again, the fillet command. But you need to know what those radiuses are. You need to know what radius to connect this line and this line needs to be. So all intersections have these curves. Where's another example here? Right? Curves here and curves here and so on. You need to know what this radius is. So you go back to the standard. Let's go back to the standards. So I'm going to point you in the right direction. When we go here, there's another table further back. I'll tell you what page it's on. table here. So it's on page 133 of the PDF. It's actually Division C, Section C 1.3. And if you zoom in on here, it gives you the curb radii, the last column. Okay. So now you have to know, is a local road connecting to a local road, a minor collector, a major collector, an industrial road, or an arterial road? Is a minor collector connecting to a local or another collector, and so on? So if a local road is intersecting a local road, this is the radius. If a local road is connecting to an arterial road, then this is the radius, and so on. Okay? So we know we're dealing with a local road. And whatever the road classification is for the existing road, does it matter what that other road classification is? Or can we just go with what's on this table? What should the curb radius be? Anybody? It's going to be 7.5. When a local road intersects any other type of road, you're always going to use a 0.5 meter radius on the pavement line, which is to say the gutter line. Okay? So make note of this page 133 in the document, the engineering standards. So that's the curb return for the road connecting to the existing road. Now, where do you draw it? That's the trick. So here's the advice. This is not a straight line. Okay, this line here is not a straight line. I'm going to trace it. Okay, so I'm going to turn my O snaps. I'm going to turn on my endpoint O snap, right? And I'm going to draw a polyline of this edge of pavement. So I'm going to connect this dot to this dot to this dot to. I'm just tracing it. Remember, it's not in the drawing. This dot and this dot, right? This is an X reference. So here's the edge of pavement on the existing road. Now, because there's no curb and gutter, the edge of asphalt is what we call the edge of pavement. So this is asphalt. This is gutter. Okay? This is an apple. This is an orange. We can't connect an apple to an orange. We have to connect apples to apples and oranges to oranges, right? Or a gutter line to a gutter line, or a edge of asphalt to an edge of asphalt. Right now, these represent two different things. This is the edge of asphalt for the existing road, and this is the edge of asphalt. This is the gutter line for the proposed road, right? They're two different things. So what we're going to do is we're going to draw the gutter line in its proper position on the existing road. Even though it's not there, I'm going to draw a line that represents where it should be if it was there, right? So what's the dimension from the edge of asphalt to the gutter line? Well, now you have to look at the standard again. So we go back to the standard. Oops, we go back to the standard. If I go back to page 130, I believe. No, 160, sorry. 164, 20 meter right of way. If you look here, it's going to say curb and gutter. So now you need to know what the curb and gutter, standard gave you. It's an OPS 0.070, and this is the dimension for the curb and gutter. Now, again, you might have seen the last year when you did your CLX course. What's the dimension in meters from the edge of asphalt to the gutter line based on this standard? In meters. What's the distance horizontally from the edge of asphalt to the gutter position based on this particular standard? Anybody? This is the asphalt here. This is the gutter line. If I know where the edge of asphalt is, how do I draw the gutter position? These dimensions are in millimeters, by the way. I want it in meters. What's your final answer? What's the distance horizontally from edge of asphalt to gutter? Try again, Caitlin. Warren, what do you think? Okay, just going to tell you, it's right here, this dimension right here, 300 millimeters, so 0.3 meters. So the existing road has an edge of asphalt. If it did have a curb and gutter based on this standard, it would be 0.3 meters away from center. So let's go back to the drawing. So if this is the edge of asphalt, I'm going to offset it by 0.3. If there was a curb and gutter here, this is where the gutter line would be, right here, 0.3 meters away from the edge of asphalt. So I'm going to delete this now. So I traced that edge. And remember, there's a bunch of dots there. See all the blue dots? Why? Because that is not a straight line. It wasn't drafted. It was actually from the survey. Remember? Connect the dots from edge of pavement to edge of pavement to edge of pavement on both sides of the road. So it's not a straight line. This is a design, right? It's offset from this line. Here, it's not drawn from the right-of-way. It's actually topographic information, connect the dots type work. Okay, so you got to be careful about that. So once I trace the line, I offset it by 0.3. Now this represents gutter and this represents gutter. Now I can fillet a gutter line to a gutter line, and that's how you do it. Okay, what was the radius? What should the curb return radius be? Yeah. So now when you fillet here, be careful, because if I use fillet with a radius of 7.5, if I do that, I connect this to this, it disappears on the other side. So you want to break it. Okay, so I want to trim it. I'm going to trim it between these two gutter lines right here. So now I have a piece on this side and I have a piece on this side. And when you fillet, be careful. Right? There's a little piece here. There's a longer stretch here, and then there's a longer stretch here. Am I going to fillet against this short line or this longer line between this and this dot? Or do I have to go all the way in this? There's 3 line segments here. I'm going to explode them. Do I fillet against this or this or this? And these aren't necessarily parallel. They look like they're all in a straight line, but they may not be. The trick is this. I'm going to draw a circle with a radius of 7.5. And then I'm just going to by eye put it where it wants to be. Right? So it wants to be between these 2 lines. It's going to be approximately here. So of these 3 pieces, this one and this one and this one, it looks like it wants to connect to this piece here. So I'm going to fillet against that line there. Okay? So I'm going to fillet with a radius of 7.5, this line here with this line here. Right? It's not going to use this piece. It's not going to use this piece. Okay? And I don't need the gutter on this road. So I'm going to explode this, and I'm going to get rid of this. And there's my curb return. So here's my gutter. Here's my gutter with a 7.5 meter radius. It's going to turn, and as soon as it's parallel, stop. There's no gutter on this road. Same thing down here, right? There's a few segments. There's 1, 2, 3. I'm just going to approximate it. I'm going to draw a circle of 7.5. A circle with a 7.5 meter radius. I'm just going to, by eye, see where it wants to be so that I know which segment to fill it against, right? It's going to be this line versus, looks like it wants this piece here. So I'm going to explode it, and I can get rid of this piece, right? So there's the line. Fill it with a radius of 7.5. I'm going to take this versus this. And again, I'm going to explode it, and I don't need this piece. Right? I'm going to take my gutter, I'm going to go around the curve, and I'm going to stop. As soon as this point and this point are 0.3 meters apart, now it's parallel to the road, and I'm done. So that's what's going to happen to the curb return. It's going to come around on both sides until it's parallel, and then we stop. Okay, so that's where the gutter ends on this curve. Okay, so it looks kind of silly because they don't touch. But remember, this represents the edge of pavement, edge of asphalt. This represents the edge of pavement, gutter line. They're 2 different things. And here's one way to tell. If I take this line here and I offset it by 0.3 meters, it should touch the asphalt, right? Edge of asphalt touching edge of asphalt. That's the check if you want. But in the subdivision, we don't draw the edge of asphalt, we draw the gutter line. So it's going to look kind of weird here that this line does not touch this line, but that's the correct thing to do on both sides. Okay. The other thing you want to be mindful of is make sure you draw each fillet separately, right? If I mirror this thing from center to center, if I mirror it on the center line, it's not the same. Why? Because the line I used for filleting here and the line I used for filleting here are not parallel. Okay, so you have to do a fillet on both sides, independent things. So don't draw one and mirror it. Draw this one with a fillet, draw this one with a fillet. They're independent of each other. They're close, but they're independent. They're different. It's a common mistake as well. Okay, so that's how you deal with the intersection. Okay, how you do this and this, well, I'm the boss. You show me. Okay, let's see how you do. Okay, the only way to learn how to do this is to fumble through it. Just interpret the information you're given and draw the solution. If you don't get it exactly right, if you get it right, great. If you don't, it's a great way to learn it because you're not going to make the mistakes again, right? So once you see the solution, it'll be obvious. But if you can discover it for yourself, that's the best thing, because everything you do in engineering is going to be something that's required that nobody else has, right? Draw this solution, right? Well, how am I going to do this? You have to come up with an idea, right? You have to figure out how to do stuff. And if somebody shows you all the time, you're just going to be somebody's, drafts person. But if you can do it yourself, then you can quickly evolve into a senior draftsperson, junior designer, senior designer, right? If you can think for yourself, then you're no longer taking instructions from other people, okay? So I'm going to do my best to leave some of the interpretation of the standards to you for you to figure out. All right, so once you draw the edge of pavement everywhere, right? So I'm just going to do a piece of it. I'm going to connect these. I'm going to join this to this and this using the p-edit command. Once you draw it, and it will go all the way around, right? So you're going to have one line. Where's the back of curb? Well, we go back to this standard. If this is the gutter line, what's the offset to the back of curb in meters? Right, remember the asphalt is here, right? The gutter line is here, 0.3 meters away. How do I get to the back of curb from the gutter line? Very good, 0.2, yep. Okay, so I would then, once I draw it, I'm going to offset 0.2, and there's the back of curb on both sides. And now I've got that double line configuration that you see in the standards in the two cul-de-sac and right, that double line, right? Gutter line, edge of pavement, and back of curb. You get it for free. So draw the edge of pavement everywhere first, and then you can offset to the outside once and for all, and you're done. Okay, and then you got to put everything on the correct layer with the right color and the right line type and so on. Okay, so that's your center line, edge of pavement. Right? We talked about center line, we talked about edge of pavement, which is to say draw the gutter line, and then you get the back of curb for free, 0.2 meters away from center. Sidewalk, where do we put the sidewalk? Well, we look at the standard again. Where's the sidewalk go? If I look at standard R1B, the sidewalk is, with respect to the right of way, 1 meter in and 1.5 meters wide. So if we go back to the drawing, this is the right of way. I'm going to offset 1 meter. There's one edge of the sidewalk, and it's 1.5 meters wide. There's the other edge of the sidewalk. So that's your sidewalk. And that goes all the way through the subdivision around the bulb and back again to the other side. So you're going to have sidewalk on both sides. How do I know? Well, there's a sidewalk on this side, and there's a sidewalk on this side. So you have to draw the double line sidewalk throughout the subdivision. Okay, so that's the sidewalk. A little bit interpret, you have to, so this is your typical 20, remember? Whoops, this is your typical 20 meter right of way, right? 20 meters wide, that's where you put the sidewalk. How are you going to deal with the elbow or the crescent? How do you go around the bulb? Well, that's for you to interpret. Okay, so again, you have to decide based on what's given here in a standard 20, where it's no longer typical 20 meters wide, where are you going to put the sidewalk? Okay, and the information you need to lead you there is in this particular drawing. Where do you draw a sidewalk? Okay, this is the standard 20 meter right of way. What do you do when things are non-standard, when the elbow or the crescent gets wider on the outside? How do you deal with the intersection? How do you deal with the crescent? Okay, so I'm going to leave that up to you to interpret, but you have to draw all that in. All right, and then the next thing is the storm and sanitary sewers. All right, we deal with these together. Why? Because in the standard, it tells you where to put the pipes. If you know where the center line of road is, then the storm sewer is on one side, 1.5 meters, and the sanitary is on the other side of center, 1.5 meters. So from the center line, storm on one side, sanitary on the other, 1.5 meters from center. Okay? So that's the standard on your typical right of way. Sewers are always straight lines, especially for small local sewers. There are some big sewers that have some radii in them, but generally speaking, that's unusual. It's a really big pipe. This is just local sewer system, storm and sand, small pipes. They're always going to be straight lines. How do you deal with when the center line is curved, but the pipe isn't? Okay, and we'll get into that in a moment. So I want to draw the center line. So how do I draw the center line of the pipes? Okay, let me just get rid of these. It's a distraction. I'm just going to use the gutter line. All right, so I have the center line and I have the edges of pavement on both sides. Where do the sewers go? Well, I'm going to offset 1.5 center line this way and 1.5 this way. So one of these is the storm, one of these is the sanitary. Okay, how do I know which is which? Well, if you look at the standard, right, if you're looking, generally the cross section is up chainage, so positive chainage is in front of you. So this side of the road is the right side, this side of the road is the left side, or you can go with the sanitary is always on the north or the east side, and the storm sewer is always on the south or the west side. That works well. That information is good if you have a grid layout of roads. But when you have a road that kind of snakes around, isn't straight east-west or straight north-south, the east side and the north side or the south and the west side, that really doesn't come into play. So I almost ignore that. What you have to look at is, do you really have a choice? Do you know which side the storm and the sanitary should be? And in this case, you'll see you don't. And what you want to look at is on the topo under, remember, storm maintenance hole in the topo and, sanitary maintenance hole and storm maintenance hole. Remember these? And I'm going to color code the storm green and I'll leave the sanitary red. Oops, storm is going to be green. Okay, so when you zoom in here, you'll see at the intersection, there's this is from the topo now, remember the X reference? You'll see the sanitary is on one side and the storm is on the other, and you'll see they're approximately 1.5 meters either side of center. So you don't really have a choice in the subdivision. This has to be the storm sewer, this has to be the sanitary sewer. So once you determine 1.5 meters either side of center, go to the topographic information and see which you're connecting to. On this side, you're connecting to sanitary, on this side, you're connecting to storm, and that's where you cut it off. And I typically draw a line on center and I trim it off. And if it doesn't trim, bring it to the other side. Trim, off you go, trim. And that's where the sewer stops. That's your connection point. All the sewers drain out to the intersection. So this is your sanitary sewer. I'm just going to color code it red, right? It needs to go on a specific layer, but just for the discussion, and this one red. And I'm going to make this one green. And then you can deal with the layers, the actual layer name and color and line type and so on. Okay? So that's generally where the sewer goes. Now the sewers can't be curved, so I'm going to explode those, and I'm going to delete the curves. These curves don't make any sense. You can't curve the sewer, right? But generally speaking, that's where the sewers should go, 1.5 meters either side of center. How do you get from here to here? Well, let me draw something. I'm going to go from here all the way to here. Now, how far apart are these pipes? How far apart are the pipes? Ignore the center line. How far apart are the pipes? How far apart are the pipes? Yeah, 3 meters. So when the road curves, but the sewers don't, in the spirit of the standard, you should keep the pipes parallel and 3 meters apart. So what I just did is I drew one of them. So where should the other one be? Offset 3 meters away. That's where the other one should be. And then if you color code it, this is storm, this is sanitary. Whenever you change direction in the plan, you need a maintenance hole. And that's where you put your maintenance holes. Every time you change direction, horizontally and vertically, but right now we're dealing with horizontal, you need a maintenance hole. Okay, so to navigate a turn, keep in the spirit of the standard. If these pipes are parallel and 3 meters apart, well, these pipes are parallel and 3 meters apart. And that's how you get around curves. Okay, now be careful. When you do that, there's 2 things you need to worry about. When you go around a curve, the pipe starts to get close to the edge of pavement. And we want to keep the sewers under the asphalt, right? So even again, here's another kind of the spirit of the standard. The two sewers, sand and storm, should be between the pavement, okay? So you always want them under the asphalt. So a bad solution would be this. If I move these further this way, now the sewer's in the boulevard, that's no good. Yeah, so you stay between these two lines. There's two limiting factors. You go around a curve, the pipe starts to get close to the edge of it. You want to maintain your distance by at least 1 meter. Offset 1 meter. Make sure there's a no-touch zone. On the inside, stay 1 meter. So this sewer is too close. So what do? I take them. I take both. I take this one, and I move them. You don't have to be exact, but as long as you're outside that 1 meter zone. Okay. So on the inside of the turn, the sewer has to be at least 1 meter away from the edge of pavement. When you move these away from center to the outside, whoops, turn my O-snaps off. If I move these away from the inside of the curve to the outside, then I have to reestablish the location of the maintenance holes. Right, so now these maintenance holes want to be over here. Okay, and then trim it off. When you move the pipes to the outside, now you run into a problem of the maintenance hole being too close to the edge of asphalt. Okay? So if there's a no-touch zone here for the pipe of 1 meter on the outside, there's a no-touch zone of 1.5 meters to the center line of the structure. So 1.5 meters, that's still good. The center of the circle has to be outside this 1.5 meter zone. And that helps keep the two pipes under the asphalt away from the gutter. Because if you ever have to dig down to these sewers, maybe we can salvage the concrete for the curb and gutter. If you put it underneath the curb and gutter, then to dig down, you're gonna lose the curb and gutter. So you try and keep it as close to the center of the road. Now, there's more than one solution here, right? I can push this further, right? I can go this way, but not any further. Now I'm encroaching on that 1 meter no touch zone. And if I go the other way, eventually I'll be in the no touch zone here. Right? If I extend to here, now the center of the maintenance hole is too close to the edge of asphalt, has to be at least 1.5 meters away. Right? So now this is 1.5 meters away, I'm too close. So there's more than one solution. As long as you have two parallel lines, right? This is too close on this side, right? That's no good. So you have to stay at least here, but you can go all the way to here, but not too far. Otherwise, the maintenance hole has a problem. So on the inside, the pipe's getting too close. You have to be at least 1 meter away. On the outside, the maintenance hole is close. You have to be at least 1.5 meters away from the center of the structure. So there's many solutions here. I could put it here, 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 anywhere in between so that I satisfy the condition. If it's too close on the inside, the pipe's going to be the limiting factor. If you're too close on the outside, the maintenance hole is going to be the limiting factor. So you need to decide where to put this. And the angle I chose, right? It doesn't have to be the first line I drew. I can rotate these two. Right? As long as I satisfy these conditions. Now, the conditions are actually in the standard, believe it or not. So let me just look at that. If we go to the sewer section of the document, oops, if we go to the sewers, you'll actually see the standard for one of them. I don't think they're both here. So one of them is a rule, one of them is a rule of thumb. So when you're navigating, where is it? Where is it? I think it's the maintenance hole. Oh, here it is. No maintenance hole shall be located closer than 1.5 from any face of curb or other utility. So that's the limiting factor on the outside. So it's on page 13. That's talking about this condition here. This has to be at least, the center of the structure has to be at least 1.5 meters away from here. Okay, now that's written in the rules. The pipe being too close on the inside, that 1 meter, that's a rule of thumb. That's just something I'm suggesting. Okay, so those are the two things you need to look. And I'm going to look for that when you lay out your pipes. And you can see there's an infinite number of places you can put them. What I'm looking for is the structure is at least 1.5 meters away from the pavement edge. The pipe is at least 1 meter away from the pavement edge, and that the pipes are parallel and 3 meters apart. That's in keeping with the spirit of the standard. So, you know, when you navigate turns, you have to do that. No, at this point here, it's a preliminary layout. I just want you to draw straight lines and circles all on one layer. And I think I specified the layer name, sand and storm. Right, so put the maintenance holes and the pipes all on one layer, all sanitary on one layer, all storm on one layer. We will eventually abandon these layers. We're gonna trace them with something a little more sophisticated. Okay, we're gonna use a pipe network, which is a database. But I just want to see where you're gonna lay it out now before you get into the database work. So it's a preliminary layout. Okay. So that's how you navigate curves. When you get to the elbows, okay, you could fill it with a radius of 0, fill it with a radius of 0. You could connect this to this and this to this. And because the asphalt is going to bulge out here, these maintenance holes will not be anywhere near the edge of asphalt. Okay? However, that's not how you do elbows. The problem with doing it like this is when you go to service these lots, and we'll do this next semester, not this semester, but when you go to service these lots, this configuration is going to cause a problem. When you put a service connection from the lot to the pipe, you want to be perpendicular. You want to be perpendicular. You want to be perpendicular. Perpendicular to this pipe? Oh, that's no good. Okay, how about perpendicular to this pipe? Well, that's no good. So this is perpendicular to this pipe, and this is perpendicular to this pipe, and the geometry doesn't work very well. Okay, so that's the problem you run into on these crescents. So what we typically do is this: in anticipation of that 90-degree thing, we draw one pipe here. We offset by 3 meters. Well, that's no good. Remember, I have to be at least 1 meter away. So I'm going to move these two pipes at least there. You could go further, but then the maintenance hole might be limited, right? And then once you draw these, and then your maintenance hole goes where these intersect. Now to service from this lot, you can go perpendicular and hit that pipe. So this short turn, it takes 2 more maintenance holes to go around the bend, right? Instead of 2, 1 sand, 1 storm, you need 2 sand and 2 storm. And that's how we service the cul-de-sac. So you need this short turn. Everybody has an elbow. This is how you service your elbow. It might not look like the most economical thing to do, but it's the practical thing to do. Okay. Now we're not going to draw all the service connections this semester. Okay. We're going to save that for an exercise next semester. It's really an AutoCAD exercise. I want to concentrate on Civil 3D for this semester. So we're not going to draw those, but we have to anticipate. So all of the knuckles need this short turn, 2 short pipes to go around the bend. Okay. Not everybody has these bends. So some of you might be dealing with this, some of you may not. But even if you're on a straight stretch, there's also a maximum distance between maintenance holes. And it's right here for storm, and there's another similar section for sanitary. Depending on the pipe size, and we don't know the sizes yet, so I would always err on the side of, assume you're building the biggest pipes, even though we're not. The maximum distance is, I assume the shortest pipes. Misspoke, sorry. So if we're dealing with the smallest pipe, 300, when you're going in a straight line, one maintenance hole can't be more than 110 meters away from the next one. And there's a similar standard for sanitary. This is the storm section. Right? This is storm. Let me see here. Yeah, so this is storm sewers. There's a similar section for sanitary, and it'll give you a similar rundown. Should be over here somewhere. Sanitary sewers, and you'll have a similar standard maintenance hole distances. Oh, sorry, maybe not. Pipes, residential flow. This is flow. Commercial sewer design. Maintenance holes. Yeah, maintenance holes will be spaced at least 110 meters apart for sanitary. So it's 110. So if you're going on a straight stretch, right? If you have a sewer, from here to here, and you list it, it's 300 meters long. You have to put a maintenance hole at least 110 meters, and then from there 110 meters, and then from there 110 meters. So you can't go more than 110 meters between two maintenance holes. So if you're not dealing with a curve, then you still have to check the length, right? So what's the length of the sewer here? From this maintenance hole to this maintenance hole, it has to be no more than 110. 47, that'll work. How about getting all the way to the end? From here all the way to the end, list that, 94. Okay, it's less than 110 and so on. Okay. So these are things you need to be mindful of, right? In the standard, maximum spacing, 110 for both sand and storm. You have to navigate bends with maintenance holes. So every time you change direction and plan, you need a maintenance hole. And when it comes to the cul-de-sac in here, or sorry, the crescent in here, you have to have this short turn in anticipation of the servicing on the outside of the curve. So that's how you lay out your storm and sanitary maintenance holes, right? Maintenance holes and pipes. Okay. The size, the slope, we'll worry about that later. I just want to see in the map where you're going to put these items. Okay. Again, in the spirit of things, you want them centered on the center line, 1.5 meters either side of center. But when you're going around a curve, the best you can do is keep them parallel and 3 meters apart. And then again, stay away from the curb line by 1 meter with the pipe and by 1.5 meters to this structure, this maintenance hole. So that's more than enough for today. Try drawing this, okay? And then the water main we'll discuss tomorrow. Okay, so for homework, if you haven't, do all of this. Draw the center line, edge of pavement, back of curb, sidewalk, storm and sanitary pipes, and maintenance holes. If you can get that done for tomorrow, you're well on your way to doing most of this assignment. The water main I'll discuss tomorrow, and then we'll get into the Civil 3D stuff, the surface, the alignment, and so on. That's a good question. Interpret the standard based on the setbacks I talked about. How close could a maintenance hole be to the end of the cul-de-sac? Right? So you kind of have to think about standards or items and then try and apply them, in unusual situations. I'll leave that up to you, Joseph. Okay, that's it for today. Come back tomorrow and we'll keep this discussion going. All right. Okay, everybody. I'll see you tomorrow. I'm going to stop recording.